In this section, we're going to start looking at graphing the absolute value function in the xy coordinate plane. So the question is asking, what is the graph of the absolute value function where y equals the absolute value of x minus 4? And how is this graph different from the graph of the parent function? Well, let's talk a little bit about parent functions. Okay, so what I want you to think about is parent functions, and there are many of them. Parent functions, well, parents are boring. That means there's not a whole lot going around with that function. So if we look at the difference between this one and this one, we can see f of x is simply the absolute value of x. There's nothing being added to the x on the inside, there's nothing being added to the absolute value, there's nothing being multiplied, nothing. This is just simply absolute value. Okay. So what we want to do is we want to create a table of values to help us to graph this. So we're going to graph the parent function first, and then we'll go ahead and we'll graph the function that they want us to graph. So with my table, I'm going to have my x column, I'm going to have my processing column, and then I'm going to have my f of x. So let's pick some values of x. So when I'm looking at absolute value, it's always a good idea to pick the center point. So let's pick the center point. It's 0 because nothing is happening around that. So I'm going to pick 0 as my center point, which means right up above it I'll have -1, then I'll have -2, and below it I'll have 2, I'll have 1, and then I'll have 2. Okay, so my process is to use the function. So the process would be the absolute value of -2, which gives me 2. My absolute value of -1 gives me 1. My absolute value of 0 gives me 0. My absolute value of 1 is 1. My absolute value of 2 is 2. So that means if I'm going to plot coordinates, I'll make one more column for my coordinates. I would plot -2, 2, -1, 1, 0, 0, 1, 1, 2, 2. And that's coming from xy, 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 xy. Okay, let's see what our parent function looks like. So we're going to go ahead and we're going to make an xy coordinate graph. Graph it right like this. Okay, and so we're going to need to put those points. So I have -2, 2, -2, 2, -1, 1, 0, 0, 1, 1, 2, 2, and it would keep going. Because it's a function, it's going to keep going. So this is my parent function, and everything we do is going to be compared to the parent. Okay? So that's my parent function. So let's look at some unique features of the parent function. Well, first of all, my vertex, which is right here, that's my vertex, and that's at the point 0, 0. Let me move this up. And that's at the point 0, 0. So my vertex is at 0, 0, right here. Okay, so the other thing that I want to notice is I'm just going to look at the right side of my absolute value. It goes over 1, up 1, over 1, up 1, over 1, up 1. So it's also just like a slope of 1. So nothing real exciting is going on. Okay, so let's go ahead and look at the other function they want us to look at, which is f of x is equal to the absolute value, I have to peek here, the absolute value of x, and then notice that minus 4 is not inside the absolute value. So that's real important to keep in mind when we're doing this. So we're going to go ahead and we're going to write our columns for this. So we're going to do our x, our process, in other words figuring it out, our f of x, and our coordinates. Now when we look at this particular function, notice there's nothing inside the absolute value along with the x, which means our center is still 0. Because our center is still 0, we'll make our x center 0, and we can take the same exact values for x that we did on the other graph for the other function. So here we're doing the absolute value of negative 2 minus 4. Well, this is 2 minus 4, so that gives us negative 2. Now we're going to do the absolute value of negative 1 minus 4. Well, that's the same as 1 minus 4, which is minus 3. The absolute value of 0 minus 4, well, that gives us minus 4. The absolute value of 1 minus 4, well, that's the same as 1 minus 4, which is negative 3. The absolute value of 2 minus 4, well, that's 2 minus 4, which gives us negative 2. So I'm going to get my coordinates from my x and my y column. So my coordinates negative 2, negative 2, negative 1, negative 3, 0, negative 4, 1, negative 3, 2, negative 2. Okay, so now I have to take this information and I have to graph it. Unfortunately, my paper right now is on my book, so let me move my book because there's a nice little crease there, which is keeping me from being able to graph this real nicely. So I'm going to go ahead and I'm going to graph this. I'm going to use my ruler, so I'm going to put my y-axis and my x-axis. So let's plot our points. So I have negative 2, negative 2. That's down here. Negative 1, negative 3. 0, negative 4. Oops, I didn't make my axis quite long enough, did I? So I'm going to just make that longer. Then I have 1, negative 3. 1, 2, 3. And then I have 2, negative 2. Okay, so we can already see that this looks a little different than what we graphed from our parent function. Okay, here's our vertex, and our vertex is at the point 0, negative 4. Okay, so hopefully, let's see here, I'm going to go ahead and zoom out a little bit so that we can see both of these graphs together. Okay, so remember this one up here is my parent function. So I'm comparing everything to the parent. So what's different from the parent and the child? Well, it looks like the child its vertex has gone from 0, 0 to 0, 4 because the parent was at 0, 0. So I'm going to actually draw in the parent function here so we can compare it on the same graph. And our parent function, we're going to use dash lines so we know that's not the function we're looking at. It's just a function, a reference for a function. So we can see here that this function went down. So it went down 4 units, a vertical shift down. So that's the difference between our new function and our parent function. So I would write vertical shift down.